This session is about writing JavaScript for C#'s Blazor. Blazor is a brand new framework from Microsoft. It was just released earlier this year. It's been in an experimental and beta stage for about almost 3 years now. So you might be wondering why you need JavaScript if it's a framework that's promising that you won't have to write JavaScript. We'll get into all of that and some patterns that you can use around writing JavaScript for your applications and hopefully building some redistributable packages so other people don't have to write JavaScript for their apps. My name's Ed Charbonneau. I'm a developer advocate for Progress Software. You might know us by the name Telerik. I work on the Telerik UI for Blazor set of tools right now. I authored a book earlier this year called Blazor, A Beginner's Guide. It's a free ebook that you can get for free. I can give you a link for that at the end of the session, or you can just search for my name. You'll find it that way. You can find me on Twitter. And you can also see every Friday my Twitch stream where I talk about Blazor and build some live applications while I'm live streaming. So that's a lot of fun every Friday at noon Eastern Standard Time. Just join me on my channel and see what I'm up to. So again, Blazor is this .NET web framework, and it promises to let you build applications using C# and Razor tooling and not have to worry about JavaScript. So why do we need JavaScript to build Blazor applications then? Well, first of all, Blazor is really, really new, and it doesn't cover everything that you need to do on the web. And the C# APIs in Blazor don't have a full API surface that matches up with the entire browser web API. There's a lot of things out there that we want to do with our web applications that just simply aren't covered by the framework itself. Those things include things like the Canvas API. There's some DOM functionality that's not quite there yet. Things like geolocation. Do I want to allow users to use a mobile device to geolocate and choose things within the application? That is not something that's baked into the framework. Even file APIs are not part of the framework. So you can't do things like file upload yet, although that's coming. But if you're writing something today, you'll still need to know how to use the file upload APIs through JavaScript to make those work in Blazor. And then web storage is another big one. And everything pretty much on this list is not covered. The only thing that is there in Blazor by default is basically some navigation and some DOM manipulation stuff that's baked into the framework that you don't see. For everything else in here, like push notifications, all of that stuff, you'll need to write a little bit of JavaScript to kind of marry that into your application. So hopefully, after I'm done with this session, you'll at least know how to work with some JavaScript in Blazor using some simple patterns. But even better, if you write these things and publish them as NuGet packages, that means other developers don't need to write that same JavaScript over and over again. So I talked about why we do need it. Why we don't is because some people have already started writing these things. We have some packages out there already. One of them is called Blazor local storage, and this handles local storage within the browser. So all you do is pull in a NuGet NuGet package, and you automatically get all of those things in a C# API to do local storage. So you don't have to write any JavaScript there. I have a media query package that handles media queries in Blazor. It's called Blazor size. So whenever you're resizing the browser or you go from a small to a large device, you can use some C# to detect the screen size that the user has and do some logic based on that. So no more JavaScript there. File uploads. The TaleLearnCode UI for Blazor, the product that I work on, has a file upload API. So all you do is add a file upload component to your application, and the user can click on the button and upload files to your server. It's just that easy. And again, you don't have to write any JavaScript there. .NET 5 is coming, and there's a lot of new APIs that are going to abstract away a lot more JavaScript there as well. A lot of these have to do with SEO and targeting things that are in the head of the application. So you can do some SEO properties and things like that that need to go inside of that part of the application. So all this stuff is building up to a framework where we don't need JavaScript, but for the immediate need, there's quite a bit of room for improvement. So what can we do in our applications to use C# to talk to JavaScript and vice versa? So there's a JavaScript interop layer built into the Blazor framework. And this lets us invoke JavaScript functions from .NET. And it also allows us to invoke .NET methods from JavaScript. So we have this two-way communication channel in Blazor that is really cool and lets us do a lot of very interesting things with the web. So how do we do it? There's actually just a small set of APIs that perform these operations. It's how you use these APIs that is really important. So while this might look a little trivial on the surface, once we get into things, you'll realize that this can get pretty sticky pretty quick. On the C# side of things, we have something called the .NET object reference. This is a typed reference, and the type is going to be the actual type in .NET, in the C# world, that we have an instance of. And we can pass an instance of this object over to JavaScript, so JavaScript is aware of our .NET instance. I've highlighted dispose here in purple, so we can kind of focus in on the fact that these are resources that we do need to manage. So there are times that we need to dispose of our .NET references. Sometimes we need to do this on the C# side of the fence. Sometimes we actually need to do this in JavaScript as well. So that dispose method is on both ends there. While we're talking about the .NET object reference, when it's in the JavaScript API, this .NET object reference, it comes across as two different things as a value. So you get your object, but it has a value of either a number or a GUID. So if you're using something like TypeScript, this is something you need to be aware of. The .NET object reference, if you're running in WebAssembly, there's only going to be one instance of that application running. So .NET can track that instance through a simple integer. Now, if you're running the Blazor application on the server, there can be a multi-tenant situation where you have multiple heads connecting to your server application. It has to track all of those instances of that object. Therefore, it uses a GUID. So depending on what your code looks like in the JavaScript world, you might need to know that. On these objects, we have a couple of methods that we can use. On the JavaScript API side, we have something called the invoke method async. This is a method that we can use to invoke a method on the C# side. So we'll take a look at that, and we'll use that in some demos today. You'll see how that works. On the C# side, we have IJS runtime. So this is an interface that we can use to call out to JavaScript and do some things. And there's two main methods here. One of those is invoke async of T. So this is a typed invoke async method. That T is going to be your return result. So if you're calling out to JavaScript and you expect a string back, then you will see that type be of string. There's also invoke void async. This is a void task that we can call out to JavaScript and don't expect anything back. We will see some usage of that in some demos as well. Now, there is something that's very important here highlighted at the bottom of the screen. Parameters and values must be JSON serializable. That's actually very easy in the .NET world, so it's not something to be overly concerned about. However, it's something that you need to be aware of, as we'll see in some demos. Sometimes things in JavaScript don't transfer one-to-one over to the C# world. So something like a datetime is different in .NET than it is in JavaScript. So when you're serializing those values from JavaScript back over to C#, you need to be aware that you might have to intervene and do some work while that serialization or before that serialization happens. So how do we do it? How do we use these APIs? This is where we're going to start breaking down and looking at some examples. And we'll do some demos as well. So the convention here is we're going to write some JavaScript that hangs off of the window namespace. So all of the JavaScript functions that we want to invoke from our C# libraries should have the namespace of window dot whatever your namespace is that you choose and the function name. This makes them accessible by Blazor and gives you some organization. The only time you don't need to specify specific namespace is if you're calling a function that directly hangs off of the window namespace already. For example, the alert. If you wanted to call an alert directly from Blazor, you don't need to specify anything special or wrap it in any kind of special namespaces. So let's look at a couple scenarios on how we're going to use JavaScript in our applications, and we'll do some demos along the way as well. The first one I want to look at is the one-way type of communication. We're going to take from C#, call directly out to JavaScript, and invoke some kind of function. We're not going to expect a return value. This happens a lot in JavaScript just because it is because we're working with the DOM in the browser. A lot of times these are UI events that we're triggering, so we don't have something tangible that we can bring back to JavaScript. A good example of this is if we're opening an alert box. If we open an alert box, we don't expect any kind of return value back from that alert box. We just expect it to open. So that's where things like the invoke async function come in really handy. It lets us invoke something from something in JavaScript from C#. We can fire and forget that and don't expect a return value back. So let's take a look. So I've got a demo application that is structured to show off some of these behaviors. And the first example I want to show is how we can use that invoke void async function. So in my Blazor application, I have a component that injects the IJS runtime. You get this by default in Blazor. All you have to do is inject it. It's already in the dependency injection, registered in that system. So all you do is pull out an instance of it, and you can do that with the inject IJS runtime. This I named JS. You can name that instance anything you'd like. I just find JS easy. I have a button on my page, and I've tied it to a C# onClick event that is going to call invoke JavaScript alert, which is a custom .NET method that I wrote that is an asynchronous task that will invoke this JavaScript function. So we'll await js.invokeAsync. The first parameter we pass into invoke void async is going to be the namespace and the function name of the JavaScript that we'd like to execute on the JavaScript side of our application. And the second parameter is the actual parameter values, the arguments that we want to pass over to JavaScript from C#. So with this, I can say example is my namespace, and display welcome is the function I want to invoke without a return value. And on the right-hand side of my screen, you can see I have that JavaScript that's going to take care of that function in the DOM for me. So I have a JavaScript file that has window.example is my namespace, and there are several functions that hang off of this example namespace. One of those is display welcome. So you can see over here where we're marrying up. If I use my annotation tool, we can kind of draw some parallels here. This invokes directly that function there, displaying window.alert, and it passes in my welcome message, which is going to be hello from C#, and it passes it over to the alert function. So we should be able to display an alert function in JavaScript from C# by doing that. So if I run the application, we'll give this a second to build and come up. Things kind of get a little bit slower when we're streaming. So if there's any kind of lag, it's not indicative of the framework, but just the fact that we're overloading the system here a little bit. So here's my example, invoke void async. If I click my button, we invoke that function from C# into JavaScript and display hello from C# in our pop-up. Okay. So that's our first scenario. That's our one-way trip over to JavaScript and executing a function. But what if we want to get some values back? Maybe we want to take C#, call a JavaScript function, get some type of value back. There is the invoke async method, invoke async of t, and we're going to do about the same thing, except this time we're going to get a return value back. And this is where it's important to remember that if it's coming back, the value is coming back from JavaScript, we need to ensure that it is a serializable value. In the example I'm going to give, it's not much of a concern because we're just going to expect back a string. So let's take a look at how that works. Oh, actually, give me a second here. I don't think I have a demo for that one. No, there we go. Sorry, I had them out of order. So again, we're going to inject our IJS runtime. We're going to invoke this method by clicking on a button. And that method is, again, a C# method that will call over to JavaScript. This time we're going to show a prompt and expect a return value back from JavaScript. Last time we just showed an alert box. This time we want to get something back. So we have a method that has an await. It's going to await the JS runtime and say invoke async. We're going to expect back a string. And again, the first set of parameters here is going to be the namespace and function that we're calling, and the value that we want to pass to JavaScript as our second argument. We're actually going to await a value this time. So we're going to set that value here, and then we will concatenate that value into a message to display your name is and the name that we type in the alert box or the prompt. On the JavaScript side, we have a show prompt method that just creates a prompt, passes in the text that we gave it from C#, and then also applies a message to type your name here. So we'll give that one a shot. So we're going to click display prompt, and this time we're going to call over to JavaScript, and here's our message, type your name here. It says, what's your name? This is the value we set from C#. And we can type our name here. And when we click OK, we'll actually get a return value back, and we can update our UI with that value. So all of those updates are very simple to do in Blazor. As soon as my result field is set, then the component will re-render that value automatically based on this click event. The system knows that there was an event triggered and it's waiting for a response back. When it gets it, the component re-renders with the new value that it received from JavaScript. Pretty cool stuff. The next demo I want to focus on is another one-way type of event. We can actually send one-way, we can invoke one-way from JavaScript over to .NET as well. So let's take a look at a code example for that. We can go directly from .NET or directly from JavaScript to .NET. On this example, I don't have any .NET code. I actually have a method here on the button click that is calling directly a JavaScript function from the normal DOM on-click event. This is not a Blazor on-click event, but a normal DOM on-click event that invokes the return array async method that is on my JavaScript side. So in here, let me back up for a second. Sorry, I need to show little. Sorry, this is round trip, not one way. This is another scenario that we run into where we want to invoke something from JavaScript into C#. raise an event and bring a value back to JavaScript. So we're actually going to have a static method in C# that we want to invoke that does some sort of task for us, and then get the values back from C# into JavaScript and do some work in JavaScript. So that's what we have here. So let's take a look at that again. We have a button on our page. We're going to directly invoke something in JavaScript from JavaScript, and then call out to .NET, execute a function, and bring some values back into JavaScript. That function that we're going to call from the .NET side of things is actually a static method. So I've got it here. It's in another class all by itself. It's a static class of static foo. We have a static task that will produce an array of integers. So we have a method called return array async, and it's just going to produce a static set of numbers 1, 2, 3 for us. But you can imagine this task might do many different things. This is any kind of static .NET function that we could put literally anything in that we want to do, and we're going to send some type of response back to JavaScript. So one thing that's really interesting about these two-way scenarios is you can kind of think of them as how you interact with your web API stack. They're very similar to HTTP calls in a way. So if you're writing web APIs, the only difference here is kind of that they're written in JavaScript versus writing them in C#, but the interaction is very similar. We're going to make a call out and expect these JSON values back, and these are all serialized automatically by the system. So we'll pull this example up, and I'll walk through it a little bit more as we do it. So this time, we're going to trigger a static method on JavaScript, trigger a static method on .NET from JavaScript, and then return values back into JavaScript. So if I pull up my console and I click on my button here, you can see I got a response back of 1, 2, 3, 4 in a JavaScript array. Okay, so this is an array in JavaScript that I received back from .NET, invoking a static method on a static class in my Blazor application. In order to do that, I'm using I'm using a JS invocable attribute. So this is an attribute that decorates our static method that tells C# that it's okay for JavaScript to invoke this method. It makes it publicly available to the JavaScript side of the application. And in the JavaScript that we execute, let's go take a look at that. In our example, we have this .NET invoke method async. So by calling the .NET object invoke method async, very similar to the way that we call JavaScript from C#, we can say this is our namespace, and this is our function that we would like to call on that namespace. And we will then take the data and manipulate that when we get a response from the .NET side of things. So we're going to log those 4 array items out to the console using console.log and display that data. So now we're able to take and do some round tripping with .NET in JavaScript. Things can get much more complex, though, if we get into scenarios where we need to have instance methods called from C#. So we actually have to take and ship over a reference to JavaScript of that instance that we need to call on our JavaScript or our C# object. So in this round trip callback scenario, we're actually going to invoke JavaScript from .NET and then invoke a C# instance method from JavaScript. So in order to do that, we need to pass off that reference to the instance of the C# object to JavaScript so it can call the actual instance method. It's a little bit different than what we just did. What we just did was a static method. This is when we're going to new up an actual instance in C#, and we need to call back to that individual instance that initially invoked the JavaScript. So this is common with a lot of APIs that you'll see. And the one that I use in the demo here today is the geolocation API. Hopefully that kind of makes sense of this callback behavior with an instance method. This is where things can start getting a little tricky, and we have yet one more scenario to cover that has a whole lot more involved in making this whole handshake between Blazor and JavaScript happen. When you're doing these type of instance calls, it's very important to dispose of those objects as well. So keep that in mind. We'll show some more demos in a little bit with dispose being displayed. So we're going to take C#, we're going to create a reference, we're going to ship that over to JavaScript. We're going to execute a function in JavaScript that has a callback. We're going to take that value, ship that back with the reference by calling the methods or the instances method with that value. So we'll take a look at that next. So for this one, I'm going to pull up a new JavaScript file over here. This is exercising the geolocation APIs that are on the browser. So whenever you're in a web application, you see that little pop-up box that asks for your permission for a website to use your location. That's the actual API that we're going to exercise next. In this example, things start to get a little bit more complex. So if you have questions, please feel free to ask them as we go along with this example. We're going to kind of push the accelerator a little bit. This is going to have a lot more function calls and a lot more expectations. So we have a view here that's going to ask if we have geolocation, if we're allowed to use geolocation. If we accept that, we're actually going to get the geolocation coordinates from my PC, and we'll post those in the browser using this code here. We'll walk over that step by step here in just a second. I want to show some data transfer objects and some functions that we're going to use on the C# side. So first of all, we have essentially what is a service. So this geolocation service, it is a class called geolocation. It has a private field of IJS runtime. So we're going to get through dependency injection, the IJS runtime, and we'll pass that off to this geolocation service. We could do this all with dependency injection. You won't see me do that here. It's not pertinent to the example. I'm trying to keep things simple. So we'll new up a geolocation class, and we'll pass in that instance of the IJS runtime and make that available to our instance. We have a value task of bool, and this simply wraps an API call to the browser that asks if the geolocation feature is even available on that browser. So not all browsers support it. Generally speaking, though, it's in this example, but if your browser doesn't support geolocation, it probably doesn't support Blazor either. That's just worth saying, but we're going to try to run that anyway. We'll just check and see if the browser has that geolocation feature, and we'll get a true or false back from that. This one's really simple. It's just that two-way communication we saw earlier. We're going to invoke this JavaScript method called hasGeolocation feature, and then expect a true or false value back. The next one's where things start getting a little bit more complex. We're going to set up a task that is called get current position. On this current position task, there's actually two callbacks available on the JavaScript API. So we're going to set up an abstraction for those in C# as well. So we'll expect back, or or we'll give it an action of on success or an action of on error. Each of these has a DTO, or a data transfer object, that serializes the position object or the error object from JavaScript over to C# and lets us handle the success or error of this task. We'll also pass in some options that we can use to set up that API. And these are all coming from the geolocation spec from the browser. So we'll set the on get position success and the on get position error. These are both actions on C# that we want to call. And then we'll invoke void async. Again, we're not going to expect anything back from the JavaScript world, because we're going to actually have two callbacks. One of these will invoke if there is a successful response or an error response from that geolocation API. So we're not expecting anything directly back when we invoke this. So we're going to call Blazor geolocation, which is the namespace of the JavaScript file. And then we'll call get current position, which is the function on that geolocation namespace. And we're also going to pass it a .NET reference. So we're using .NET object reference.create, and we're passing this. So I'm giving JavaScript the actual reference to this very geolocation instance that we're creating. So it's aware of that geolocation instance because it needs to execute one of these two callbacks on this instance of the geolocation class. So we're going to pass that instance over to JavaScript, and we'll also pass over any options that we have to set up that API on the DOM side in JavaScript. Now, we have the success and failure routes here. These are JS invocable. So we're going to invoke some C# methods from JavaScript when those callbacks are finished. So we have the raise on get position and raise on get position error. So we have our success path and our fail path that are going to light up when those JavaScript executions or functions execute. So give me one moment here. Just want to make sure. Sorry, I was double checking to see if we had any questions. Looks like Dan had a question. Can you pass a payload to the invoke call from JavaScript to C#? If you can define what payload means, and I may be answering that in this next question here, or this next example here. I think I might be covering that in just a moment here. So when the JavaScript side executes the call to the geolocation API, it's going to come back and it's going to invoke one of these JS invocables. These are just very, very simple handlers that will pass off that delegate to whatever the developer that is consuming this geolocation API has specified. So we're going to call on position, on get position, and invoke that and return the values from JavaScript. And this may be to your question, Dan. So if the browser supports geolocation, but the hardware does not, do you find out? Yes. So that will actually be in the error part of this. And I don't know if I can demo that, but I can at least show you where that code would light up. So these raise on get position, raise on error positions don't really have any logic in them other than that they invoke a method that the user has specified and pass in any values that the JavaScript function has returned from that geolocation API call. There are some DTOs or data transfer objects. These are for serialization between the browser API and to have something in C# that we can kind of shape to a data model. So we have our options, we have coordinates, and position contains coordinates and a date timestamp. The error position error will give us one of these three errors, and these are all defined in the DOM API standards. Not only the errors, but all of the position and coordinate values are all coming from the web standards for the geolocation API. So our position errors are permission denied. That's if we click on the block button when that prompt comes up. We would have a permission denied error. Position unavailable is if geolocation, I think this might be to Greg's question. I believe position unavailable comes up if the browser supports it, but the hardware does not, or for some reason there isn't a correct response coming back from the geolocation on the device. And then timeout would happen if the geolocation is supported, but for some reason it's taking too long to return the coordinates from the device. So Greg, I think your position unavailable is the error you would see. And then to Dan, these are all payloads coming back from JavaScript and being serialized into a C# object. So let's review the JavaScript now. So we're going to call from C# get current position. That passes off its call to get current position on JavaScript. And if we look, I won't cover the has geolocation feature. It's just going to simply return true or false. But we have the get current position function here. And you can see an on success and an on error callback routine here. So we have our success and fail paths. We also have in our function a geolocation reference. This is our .NET instance reference that I'm passing an instance of the geolocation class to JavaScript so we can do some callbacks on it. So when we're on a success path, you'll see that the geolocation reference .invoke method async is called. And we're going to invoke raise on get position from it. So in our earlier example, you saw me invoke a static method from JavaScript. This time we actually have an instance method, so we don't need to call the namespace and all of those things. We just need to call the actual method, because this will point back directly to this raise on get position function and tie these two things together. So we have on the JavaScript side, we're going to set up a success callback that will then hand off to .NET and call the actual instance of this geolocation method. And we're going to invoke async this raise on get position method and send that and invoke that method here. And we're going to send back the geolocation response. Or sorry, that pointed at the error method. We're going to send back the geolocation response here as a position. So .NET will actually take that JSON response and serialize that over. Now, serialization here is really important because we have something in here that causes some problems. If I look at what a geolocation coordinate is made of, it has coordinates of latitude and longitude, but it also has this position value, which is the coordinates at a time. So not only is a position the coordinates, but it's also the exact time that it happened as well. So you might have, there's actually another function that we could call here that does more of a watch, and it's a consistent update as that user moves. Say you're building a fitness application and you want to track the user's position as they run over a course. So this date time can be really handy for that. The problem is that date time is not something that is .NET friendly when it's in the JavaScript world. So we don't have a way to represent that other than date time or string. I personally would rather have it serialize across correctly. So you'll see in my callback method here, we're going to actually call an internal method in JavaScript first that's going to make the data serializable. So we're going to take the results from our geolocation API, and we're going to pump those into a method called toSerializable. Now, this takes the JSON response back from the geolocation call. It simply passes off the latitude and longitude, as you can see here. But what's important is it takes the timestamp and it news up an instance of a date using the timestamp that came back from the geolocation service. Now, this new date will actually format this timestamp in the proper serializable response that .NET understands. So once we have this object, we can return it directly over to a position and it will serialize out correctly. So you'll see that in both the success and the fail, or sorry, you'll see that in the success message that we're going to call toSerializable first. That's going to shape our data for us so we can get it across the boundary. And then the error is simply returning an error code that matches up with our enumerator on the .NET side. Now these are just setting up the success and fail delegates here. The actual work is being done on the next line, which says navigator.geolocation. This is the actual DOM API call. So we call navigator geolocation get current position. Then we give it the two callbacks and any options that we want to set on that API call. Those options are things like our timeout. So we can actually specify a custom timeout. I can't remember off the top of my head what age is. And then there's high accuracy, which I think is something that is only available on certain devices. So we could set that as well. But we can pass those options into this method call. So the method call fires off, but again, remember, there's no return value here. So this is an async void call. So it's a void call. We're not expecting anything directly back from get current position, just as you don't get anything back from navigator geolocation get current position. Everything return value wise is handled by these two callback functions. Those callback functions then invoke .NET. .NET then raises another event or invokes another method, which is whatever the developer specified as the way to handle that. So let's take a look at how it's handled now. So if we go back to our geolocation view, we can look at how this is being consumed. So now we have we have our IJS runtime, and we have some code here. This is UI code. So we're going to say if there is if the browser supports geolocation, we'll display a p tag that says browser has geolocation. On our success path, if the position is not null, then we'll go ahead and display the position's coordinates, the latitude, the longitude, and the timestamp that was given for that. If it fails, then we'll go ahead and light up the UI for the failures. We can say position denied, unavailable, or timeout. These will only display if any of these things happen. So if we have a success, there's no else statement in here because the fail will catch that failure state. If there is no position and it failed, then this won't light up. So you'll only see one of these at a time. To use the API, we'll set up a null position and we'll set up a null error. We'll also set up a flag for if the geolocation is supported. The important part here is we have on success and on error. These are my developer defined callbacks that I'm going to use to handle that response. So my success here is simply echoing it out to the display by setting the position from null to whatever I get back from the geolocation API. But you can imagine I might want other functionalities in here. Maybe I'm selecting my location off of a dropdown. Maybe I can detect what physical state, region of the country that person is in, and select it from a drop-down box for them, and pre-set up forms, things like that. So this on success is going to be very important from the developer that's consuming my C# API. I'm handling everything as far as calling the geolocation in a task called on after render async. This is very important because a lot of times when people are developing these JavaScript interop APIs for the first time, they try to fire things off in the onInitialized async event in the component. Now, onInitialized async fires when the component initializes for the first time. What's interesting about Blazor is it can run in different scenarios. So it may be running server side. It can be running client side in WebAssembly. It can run server side in .NET. Depending on which scenario you're running in, your JavaScript may not be available at the time the component is initialized. So if you think about how the server side of Blazor works, if I'm initializing a component and pre-rendering it on the server, I'm rendering out that component to send it down to the client that's going to then view it. JavaScript isn't available on that server. So if you try to do that on the initialization lifecycle method, then you may run into an error depending on whether you're using WebAssembly or you're using .NET on the server. So instead, what we can do is use on after render async. So this will only be called after the component has actually been rendered and viewed on the client. So we have reassurance that JavaScript will then be available when this happens. So we want to use on after render async, and we're going to check and see if the component has ever been rendered before. If it hasn't, we'll go ahead and new up a geolocation API, give it the JavaScript instance. We'll call the has geolocation feature and set the field to true or false. We'll go ahead and set up our options, and then we'll call get current position and await that success or that error. Once the success or error happens, it will either create a position object here and replace that null position, or it will replace the error position, and that will either light up the pass or fail UIs that we have there. So if I navigate to that page, we can refresh this again. You can see the browser has geolocation. My current position is this, and the position was reported at this time. Not sure where that time got translated from. I might want to look into that one. There might be a little serialization issue still lingering there. It may be coming across as UTC time or something like that. So it's not a localized time value. The next one I want to show you gets even deeper into the types of scenarios that you may run into. We won't have time to go over this in great detail like we did the geolocation calls that we made. There are some instances where you have JavaScript that you want to tie your application to that you're listening for these events to happen in the JavaScript world and invoking many different things inside of your application. You may want this API to be consumable by many, many components in your application. Therefore, we need to do some different handling. Geolocation, generally, you're going to detect that at the page level, and you're only going to do that kind of thing once, and then you have that value. You may be tracking it over time, but you don't have multiple instances of geolocation per application. there's only one geolocation sensor, and the person can only be in one place at one time. Whereas the one I'm about to show you, there could be many, many instances of this object floating around in your application, and there's some considerations that we might want to take here. This is a media query listener. So what it does is it listens for the browser to change its media query. This could be many different values. I have one set up at this current time in the application here. So it will detect if I'm on a small device or if I'm on a tablet or desktop device. And you can see as I scroll my screen back and forth, it's actually detecting my browser's size in real time based on a media query. So if it's below a certain value, it will trigger a small device. And if it's above that value, it will trigger something else. Again, I could have multiple components all detecting different screen sizes to do something different based on those screen sizes. So I might have a component that is looking for a mobile device. I might have a component that wants to know if I'm on a tablet. I might have a component that wants to know if I'm on a desktop, and I might have a component that wants to know everything in between those things as well. So this can be many, many instances of this component. You could think of a data grid might be looking at this on a per column basis to show or hide columns and so on. I mean, it can get really, really deep very quickly. So we have another pattern that I want to show very quick. We're almost out of time here. This is a publisher subscriber pattern that I'm using for my Blazor size package that I have on NuGet, the one that I just showed that detects the screen size. So what's special about this one is we actually have a pub sub type of a pattern that's working along with C# and JavaScript so that we do not pollute JavaScript with a bunch of DOM event listeners that we don't need, and then we don't pollute C# with a bunch of extra instances that we don't need there. So the way this works is we have multiple components in our Blazor application that want to listen to some DOM events. So we may have a component listening to DOM event A, and another one that listens to A and B, another one that just listens to B, and another one that listens to both A and B. So what we don't want to do is add multiple event listeners and start duplicating things. So when we initialize something like component A, what we don't want to do is when we initialize another component and it looks for that that same DOM event, we don't duplicate that DOM event and create yet another listener looking out and invoking methods in C#. So we don't want like this callback hell going on where we have a ton of DOM events triggering a bunch of C# things and a lot of its duplicate events that are invoking. So what we instead want to do is we want to look for these duplications and dedupe those if we can. Another thing is when we start removing objects from our C# code, if we have a page full of components, we navigate away from that page, those components are destroyed and disposed of. We don't want to leave DOM events lingering in JavaScript trying to make callbacks over to C# to objects that don't exist anymore. Okay. So we need to have this, we need a way to track all of this. We need some sort of manager that's going to handle these handshakes back and forth and let each side of this equation know when things are disposed of and clean up the event listeners when they need to go away in JavaScript. So that's how this one works. Now, I don't have time to go into all the details of it, but the page that you just saw works kind of as follows. There is a media query list component. This component ties into all of the lifecycle events of the Blazor application and tracks when these objects go in and out of scope in C#. And it sets up a queue or kind of a state management in JavaScript that tracks these objects. is very easily done with that .NET instance that we can pass over, and we also need to actually track the .NET callback method on the DOM as well. So to try to make a long story short there, if you try to just track, say, an add event listener in JavaScript, you actually have to track that very instance that you create, or you can never remove it again. So we need to be careful of that as well. So you'll see in the media query list, it tracks the ID, which is itself. It tracks the .NET callback, which is the events that are taking place in the DOM and pushing back the callbacks into C#. And then we have a list of the media query components that are newed up on this side. So we look at the code for that. You're not going to see, first of all, you're not going to see me newing up an instance and doing any kind of method calls, because I'm leveraging the component model of Blazor to handle all of this for me. So this code is all abstracted away from the user. So when you install the plugin, let's see here, match media. When you install the plugin, you're not going to see any JavaScript other than what is referenced in the head of the application here. So you'll see I have this script is content Blazor Pro Blazor size, which is the namespace of the plugin, and this Blazor size min.js. It's the only JavaScript reference that the end user is going to interact with. Other than that, there's no JavaScript for the user that is picking this NuGet package up and using it. Instead, they drop a component in their application. This would be at the root level of their application. I just put it here to make it easy to see. So we have our media query list. This is the manager that's going to look at all of the instances that are created and make sure that we're deduplicating any callbacks for media queries that already exist in JavaScript that we're already listening to. We don't want to just invoke wildly a bunch of stuff. Again, server-side Blazor, this is where you can get into a lot of trouble, because if I'm listening to 100 event listeners on JavaScript, I'm essentially going to make 100 WebSocket requests back to my server when that triggers. So we want to deduplicate those down and make that as least amount of calls as possible, hopefully one. That's what our media query list manager is doing for us. Anywhere in my application, if this is at the root level of my application, I can create an instance of my media query component just by adding the component to my view. And then I can set the breakpoint I want to listen to. So the screen width, in this case, it's maybe a little hard to see here, but it says max width of 767 pixels. Whenever I hit that threshold, I'm going to toggle through data binding whether it matches that value or not. When I do that, I can decide in my UI how I want to handle that. Do I display the H1 tag of small device? Do I display tablet or desktop? This could be any number of components I could display in here. So if I have, say, a data grid with many columns, I can hide certain columns, or I can even switch that entire data grid over into a list of cards instead, something that is a little more vertical friendly for a small device. But the user themselves, they don't have to write any JavaScript for this. They plop two components on their page in their application, and now they have this nice way to control their user interface. So I suggest, if you want to learn how all of that works, to check out the GitHub package online. I'll give links to that in just a moment. That package takes, or that GitHub project takes into account all of the lifecycle methods and shows you how to use those in context of that that NuGet package. As far as all of the tooling and testing involved in creating that, I used NPM. I used Jest for testing. I used TypeScript in that instance and compiled that over to JavaScript. Then Rollup takes all of that information and puts that into a single JavaScript file that the user can put on their page and call into their application. So we are at time. I just want to thank everybody. Sorry if I'm going a little long here. You can go to edcharbonneau.com and you can find all of the links to my GitHub page for Blazor size. I have a free ebook link there as well, and blogs at TaleLearnCode.com has a lot of great information of our for our blogs. Does Blazor prevent any protections to prevent someone from injecting JavaScript to, for example, invoking .NET methods that new up objects that need disposal, causing DDoS attacks on the server? I don't know about. That's something I haven't looked into. Feel free to hit me up on Twitter and ask me that on there as well. We could pass that off to some of the .NET team that might know a little better. You could potentially flood a WebSocket. I don't know how that's going to affect your server. At the end of the day, there may be some safeguards in place for that. I'm not sure though. I can't answer that directly. But I'd be happy to follow up on another forum because I know we're out of time. I think this keeps on going though. So if anybody wants to stay and ask questions, I don't feel like this interferes with any of the other sessions going on. So I'm happy to stay around for a few minutes and answer any more questions. Thanks, Greg. I wish I had a little bit more time to get into some of the Blazor size stuff. Make sure you check that one out on GitHub. The patterns are a little bit tougher to follow, so it's hard to cover in a session. So it's best probably to look over the project on GitHub. I'll try to paste that here for you all as well. There's some really good stuff that you can pick out from that project that will apply to many JavaScript scenarios, especially if you're writing packages that are for mass consumption, not just for your own organization. These patterns will help you make those things more easy on the developer experience side of things. So make sure you check that out. Thanks, everybody, and I'll see you tomorrow. I have another session on building components. So take care. Have a good day. Thanks, Lewis. We'll see you soon, hopefully. Hope this thing is over pretty soon so we can meet in person again. Take care. Bye-bye.